All right, we're going to be doing a lesson on factoring the difference of squares. And so our objective is to factor binomials, that are the difference of squares, and solve equations. And you've done factoring and you've done solving, but now we're going to do it with application to the difference of two squares. All right, some review. A perfect square is a rational number whose square root is a rational number. Okay? So let me give you an example of this, what I'm talking about here. If we have 36, we have 36, and we take its square root, that's 6. Okay, we're not talking about, well, numbers that do have decimals and fractions in them are still rational. When we're talking about the coefficients here, we're going to just be looking at integers actually. But the other thing with perfect squares, so why we use the term rational number, is we could have something like x squared. Well, the square root of x squared is x. Okay, so perfect squares can exist as integers, but it can also exist as variables. Another one we could have is, say, x to the 4th power. Well, x to the 4th power, if we think back to last unit, is really x squared to the 2nd power. And if I wanted to take the square root of that, that would just be x squared. Next, let's review the zero product property. Now, we looked at this way back in the beginning of the year, and this is something you've been doing in math for years. But remember, the zero product property basically says that anything times 0 equals 0. So A times 0 equals 0, right? Anything times 0 has got to equal 0. So that if we end up with something in factored form where it's two binomials being multiplied by each other, and they're set equal to 0. Well, we know that if the first one, if x minus 2 equals 0, well then 0 times x plus 6 would be 0, so that would work. And then we also know that if x plus 6 equaled 0, well, if that whole thing was 0, then 0 times x minus 2 would also be 0. So either way, we would get 0. And remember how this would look, how we would do this and solve, this would give us actually a couple of solutions for x. We would first say x minus 2 x minus 2 equals 0. We add 2 to both sides of the equal sign, and so that cancels and we get x equals 2. So that's our first answer. But we also have another answer, because we can say x plus 6 equals 0, subtract 6 from both sides of the equal sign, so x equals negative 6. So there are two possible solutions, and let me just show you how that would work. So if we put in 2 for x, so we'd have 2 minus 2 times 2 plus 6 equals 0. Well, that would give us 0 times 8 equals 0. So it works. And if I tried negative 6, I would have negative 6 minus 2 times negative 6 plus 6 equals 0. So you'd have negative 8 times 0 equals 0, which is also a true statement. So that's how the zero product property helps us with solving quadratics. And finally, let's look at our new material, which is when we're factoring the difference of two squares. So in a variable form, we just say m squared minus n squared equals m plus n times m minus n. And let me give you an example of that with an actual situation. If I have x squared minus 25. Okay, well, x is a perfect square and 25 is a perfect square. So m in this situation, m is really just x because it's the square root, right? X squared is m squared. Okay, so m is just x. Next we have 25. Well, the 25 corresponds to n squared. So to find out what n is, I just have to take the square root of 25. So n is actually 5. So to factor this, I would say that it's x minus 5 times x plus 5. And that would be x squared minus 25 in factored form. And I could check this by doing the distributive or FOIL. X times x is x squared. X times positive 5 is 5x. Negative 5 times x is negative 5x. And negative 5 times positive 5 is negative 25. The middle terms will cancel out, so we end up with x squared minus 25. Okay, so by having that plus minus, having a plus and a minus, that's what gets rid of those middle terms and allows us to just have the a squared minus c. Let me give you one more example of this. If we had 36x squared minus 49y squared. And I wanted to factor this as the difference of two squares. Okay, well, my m squared is the 36x squared. So m is the square root of that. Well, the square root of 36 is 6, and the square root of x squared is x. So there's m. And then I need to figure out what n squared is. Well, n squared itself is 49y squared, so n is the square root of that. The square root of 49 is 7, and the square root of y squared is y. So I can put that together and factor this binomial and say that its factored form would be 6x minus 7y times 6x plus 7y. And that would be the factored form. Now, another thing to remember is that sometimes you have to factor more than one time, and you can't just stop. For example, if I have x to the 4th minus 81. Well, the m squared in this situation is x to the 4th, so m is the square root of x to the 4th. So m is actually x squared. And then in this situation, the n squared is 81. So n is actually 9. So when I go to factor this, I'll end up with x squared minus 9 times x squared plus 9. But I'm not done. Now the x squared plus 9 is done. I can't factor anymore. There is no such thing as sum of two squares and being able to factor. But this x squared minus 9, that is also another difference of two squares. And so I would need to repeat the process. So in my new situation, m is now x, because that's the square root of x squared. And n is now 3, because that's the square root of 9. So I would have to continue factoring. So if I continue factoring, the x squared minus 9 becomes x minus 3 times x plus 3. But I also must carry down the x squared plus 9. That does not just disappear. So when you're factoring and you're asked to factor completely, as long as you can keep factoring, you must keep going until you get to the most complete factor. Remember, that's like when we did, let's see, something like, trying to think here, say I had 10x squared y, and you were asked to completely factor it, that would be 2 times 5 times x times y, right? I get into the most factorable forms to where everything left is prime and cannot be factored. And that's what I did here as well. I went to a point where I could no longer factor anymore. All right, there is another video going over some practice problems. You should take a look at that too.